So let's begin. So tell us there very far that a matrix is a rectangular. Is a rectangular arrangement, or what at times you'll get some examiners call array of numbers. Arranged in rows and columns. So e.g., we have here 3, 8, 2, 9. So this is a matrix. You can see we have got 2 rows, 2 columns there. So order of a matrix. So we normally use Roman Catholic. Yeah, i.e. rows by columns, like that. So for example, if you have 1, 2, 3, we have 4, 5, 6 like this. This matrix has got how many rows? I know that rows move like this, row 1, row 2. These others moving down, these are columns, like that. So columns are 3, rows are 2. So basically the order of this matrix is 2 by what here? It is 2 by 3 columns. 2 by 3 columns. It's 2 by 3 columns. Now we have many types of matrices. Types of matrices. Types of matrices. You have what we call a row matrix. So a row matrix contains one row only. E.g., 1, 4, 5 is a row matrix. A column matrix contains one column only. It's moving down like that. Number 3, we have what we call identity matrix. An identity matrix is a matrix whose main diagonal elements are 1, and the others are 0. E.g., if you have an identity which is a 2 by 2, it will be 1, 0, 0, 1. So you can see the main matrix here, the main diagonal of this one. Yeah. As 1, 1. And all the others are what here? 0. All the others are 0. If, for example, we have an identity which is 3 by 3, it will be 1, 0, 0, 0, 1, 0, 0, 0, 1. So you can see the main diagonal has 1s here. All the others are 0. All the others are 0. Could you kindly confirm that you are together, that you guys are able to follow what I'm discussing? we really together? Let me just check. Thank you so much. Thank you so much. A square matrix so this is any matrix whose number of rows equals number of columns. Like now what we have had up here is a square matrix. E.g., for example, we could have a 2 by 2 square matrix, to be 3, 8, 9, for example, 4. So you can see we have 2 rows, and 2 columns. That's a square matrix. We could talk over a 3 by 3 square matrix, like 4, 9, 6, 5, 8, 1, negative 1, 4, 3. You can see here we have 3 rows and 3 columns. So any matrix whose number of rows equals number of columns will be called what here? A square matrix. Then from there we have a scalar matrix. Scalar matrix. This is a special type of a square matrix in which column number 1, all diagonal elements are 0. No, all diagonal elements are equal to all of diagonal elements are 0. E.g., here we have 5, 0, 0, 0, 5, 0, 0, 0, 5, like that. All diagonal elements, you should talk of all main diagonals, sorry for that. All main diagonal elements, the main diagonal is this one here, 5, 5, 5, 5. They're equal. All of diagonal elements are what here? 0. So a very good example of a scalar matrix will be the identity. You see identity, we talk of 1, 0, 0, for example, 0, 1, 0, 0, 0, 1. You see all the main elements here are equal with all of diagonal elements. These are equal with all of diagonal elements being 0. I'm just giving you 2 minutes for this sink in. Then we go to the next one. Number 6 is what we call a singular matrix. A singular matrix. This is a matrix whose determinant is 0. a matrix whose determinant is 0 is known as what here? A singular matrix. So we shall be writing determinant like this. Yeah. For example, for you to understand very well, ladies and gentlemen, if we are given a matrix like this, example, if matrix A is 2, 4, 1, 2, kindly determine its determinant. Determinant, we call it like this. And to get determinant, we normally take PPD minus PSD. PPD minus PSD. PPD stands for product of primary diagonal. Product of primary diagonal. And the PSD stands for product of secondary diagonal. See, product means multiply. Now, my good student, we have got two types of diagonals. You have a rectangle like this, A, B, C, D. So AC is the primary diagonal, is the major diagonal. BD will be the lagging or a secondary. Yeah, so the diagonal that starts from the beginning here is what we call primary. So if you've got a matrix like this, you see this is the first element of this matrix. That diagonal which runs like this from the first element is what we call primary. So I want you to go ahead and multiply product of primary diagonal. So this will be 2 times 2, giving me 4. And then we have 1 times 4. Product of secondary diagonal. 1 times 4 is 4. You say the symbol of determinant is like this. You say determinant is PPD minus PSD. Product of primary is 4 minus 4. So 4 minus 4 gives me 0. Any matrix whose determinant is 0, we call it a singular matrix. And as we shall be seeing later on, singular matrices do not have inverses. Singular matrices don't have inverses. They don't have an inverse, no inverse. Singular matrix doesn't have an inverse. Doesn't have an inverse. So now, ladies and gentlemen, first of all, let me get confirmations as to whether we are together up to here, please. I don't want to leave anybody behind. Yeah, they're saying we are together. And how many are they now? 30-something. Great. If you look at your past papers, you will get some other funny type of matrices. For example, number 7, they may want you to define a vector matrix. A vector matrix. A matrix that has 1 row or 1 column, like this. We can talk of a row vector. Yeah, e.g., A equals 2, 4. These are row vector matrix. It has only 1 row. And then we have in this case here column vector. This one has only one column. Yeah, like B 2, 8, 9. So this is a column vector. So any vector matrix is that matrix that has got either one row or one column. All right. Now, I would want to go to the algebra. I would want to go to the algebra. There are so many really types of what here matrices. If you remember, for example, we have at times I've seen this from your past papers just now. Like you will get in this case your examiner telling you something to do with a null matrix. A null matrix. Null is 0. All elements are 0. Like that. So e.g., if you have 0, 0, 0, 0, these are null matrix. Then you can talk over, there are so many. There are so many. We have, for example, a diagonal matrix. These are the same as scalar matrix, no? The most important thing you're supposed to know here under this diagonal matrix is that non-diagonal elements are 0. The main diagonal, they don't have to be 0. Like, for example, if you have 2, 0, 0, we have here 0, 5, 0, 0, 0, 9. You see, like now, this one cannot be a scalar because for a scalar, it's 2, 2, 2, 2. Right? These one, they are different, but you can see the non-diagonal elements, all of them are what here are 0. We call them what here? We call them, to be very, very important for you to be able to appreciate that. Now then we go to the matrix algebra. Matrix algebra. So when we talk of matrix algebra, what do we mean? It is a branch of mathematics that deals with the manipulation of matrices, the manipulation of matrices through operations such as addition, subtraction, multiplication, transposition, and inversion. So we're able to combine like matrix addition and subtraction, we do them together. So right there, matrix addition and subtraction. Matrices can only be added or subtracted if they are of the same order. If they are of the same order. And how do we do this addition? Same order matrices. So if A is 3, 8, negative 1, 5, and the B is 2, negative 3, or negative 8. If you're told here to come and add them, so A plus B, how will this A plus B look like? How will this A plus B look like? Now, my very good students, please listen and listen to me very well. Listen and listen to me very well. So what is going to happen here is the fact that you will be taking here, you see we have this element corresponds to this. Same position element shall be added. So same position. So we have here 3 plus 2, that gives me 5. Same position. How about this 8 plus minus 3? Is there anybody who can give me this figure? 8 plus minus 3? 5, right? So I'm being told it's 5 as well. Then we have here minus 1 plus 4. Same position, this and this. So minus 1 plus 4 gives me what here? 3. Lastly, we have 5 and minus 8. 5 and minus 8. Same position, minus 3. If you have your past papers, please make reference to this question. Question number 1, part B. So last semester, this was April 2026. Question number 1, C. Once you get it, could you kindly mention there, yes. Thank you so much. So please go through the question yourselves. We want somebody to share. So once you get it, I would want to know whether I've gotten it. Yeah, somebody has even actually shared the question paper. Please then allow me to simply go through. It was very easy, really. Actually, this is supposed to be part B, eh? Sorry for that. Part B. Very good. So we are told here, a logistics company in Mombasa manages the transportation of two types of goods, A and B, to two destinations, Nairobi and Kisumu. Matrix A represents the number of truckloads, tens allocated to each destination, while matrix B represents cost adjustment factors in shillings thousands per route due to changes in fuel prices and road conditions. So we have A 4213, B 21352. Management wishes to analyze the combined effect of transportation allocations and the cost adjustments. You can see for 4 marks, they want us to determine the matrix A plus B. I want to believe that is something you can do very easily without my help whatsoever. True or false? So remember, there are two matrices that we have, ladies and gentlemen. We have A 4213 21. Then they want us to simply give them A plus B. So basically, we are adding corresponding elements. Whenever you're adding or subtracting, you work with corresponding elements. So we have 4 and 2. So that will be 4 plus 2. The next one will be 2 plus 1. Then 1 plus 3. 1 plus 5. 1 plus 5 here. Then 3 plus 2, like that. Corresponding elements, which basically will be 6, 3, 6, and then what here? 5, like that. So you basically add or subtract corresponding elements. Yeah. Now remember they had given us this. They're saying that matrix, a logistics company Mombasa manages transportation of two types of goods, A and B, to two destinations, Nairobi and Kisumu. All right. Right. Yeah, matrix A represents the number of truckloads in 10 allocated to each destination, while B represents cost adjustments factors per route due to changes. Now listen and listen to me very well. So basically, here we have our matrix A. So we have two types of goods. So we have here A, B, and then of course the columns here will be our destinations. We have Nairobi, and then we have what here? Kisumu. Nairobi and Kisumu, like that. Because you see, if you look at this very well, they wanted us to interpret what this 6 stands for. So 6, of course, will be the cost of transporting A to Nairobi. Now, but the adjusted cost, because you see when you are multiplying, this B was the adjustment factor. Maybe we have this Iran, US wars, leading to adjustments of fuel prices. So these are adjustment factor like that. So they wanted us to interpret this, and this is what most students were not able to get right. So when you are interpreting this, ladies and gentlemen, so we have here these six, the six, we are writing them down. Combined effect, combined effect of transporting goods A to Nairobi, combined or adjusted transportation costs. So 3 will be the combined effect, combined because we added of transporting still goods A, but this time around, Kisumu, like that. Then we have these other 6 here now. So it's goods B, Nairobi, adjusted cost of transporting goods B to Nairobi. So this one here. Then B to Kisumu, the 5 like that. I suppose you've gotten an idea, ladies and gentlemen. Even if you were to speak about just the normal transportation cost, then that would still be okay. That would still be very okay. Then, ladies and gentlemen, up to there, have you been able to see how we normally add the 2 matrices? The concept here was for us to simply do what here? Add. Interpretation is neither here nor there. So long as you understand what goods we have, the destinations, you'll really be able to put in your own language to. I just want to know whether we are together up to here. All right, and today we are so many, we are 40. Now, the same case, ladies and gentlemen, is applicable to subtraction. So whenever we talk of subtraction, the matrices must be of the same order. The matrices must be of the same order. So for example here, we're given 3, 9, 4, -2. We are told to subtract 8, -3, 4, -2, like that. To subtract. So first of all, these are 2 by 2 matrix. These are 2 by 2 matrix as well. So it means that the two are compatible for purpose of what here? Subtraction. For purpose of subtraction. So please go ahead and subtract for us. What do we have here? So we have here 3 minus 8. Subtract corresponding elements. 3 minus 8. Then we have this 9. This minus. And the number itself is minus 3. Then we have 4 minus 4. That's 4 minus 4. Then we have minus 2, this one. Then there is this minus. This number itself is a minus. So could you kindly give me these resulting answers? So 3 minus 8 will give me what figure? So this is minus 5. This is 9 minus 3. 9 minus 3. Interpretation, okay, I will be able to repeat. Minus 3. 12. We have 4 minus 4 is 0. To be careful here, put those many minuses in your calculator to avoid interpretations. You have minus 2, minus, which will be what here, somebody? 0, if I'm not wrong. So are we okay up to here except the interpretation? Okay, up to here. You see, we have in this case here our two products. The final matrix we got was 6, 3, 6, 5. So we have here product A, product B. The columns that we have here, these are which columns? Nairobi versus Kisumu. You see, this is the cost of transporting, goods from A to Nairobi. 6. This 3 is the cost in a car to transport goods from A to Kisumu. The same case in this case here with this B, Nairobi. Goods of transporting goods from B to Nairobi, 6 like that. Same case with this. I suppose that's a little bit comfortable now. As long as you are able to connect the squares, then you can never go wrong. The terms you use really is not neither here nor there. The most important thing is you understand that these are transportation cost matrix. Which then now takes me to matrix multiplication. Matrix multiplication. So matrix multiplication, my good student, what do we have there? So under matrix multiplication, this is what you're supposed to know, right? Matrix multiplication is only possible when m times n, the n times p matrices are involved. When multiplying two matrices, the inner numbers, this n must be the same for the two matrices to be compatible. But the number of columns, the number of columns, the first matrix, in the first matrix must equal to the number of rows in the second matrix. See, this is Roman Catholic. I gave you this, Roman Catholic. So the number of columns of this matrix must be equal to the number of rows of the second matrix. Very, very important for this really happen. See, you are given 238, 461. We're told to multiply this with 457, 69. So the first thing you're supposed to do is to write the orders of these two matrices. You write the orders of these two matrices. Can somebody tell me the order of the first matrix? Anybody who is able to see the order, the first matrix? Order of the first, which question are you asking? Please. The order of the first matrix. Is it a 3 by 3? First matrix. I can see it has 2 rows. Thanks for trying. It has 2 rows by 3 columns. It is 2 by 3 because the columns, you can see the columns are moving down like this. Columns like the pillars of the house. Yeah, they stand vertical like that. So these are 2 by 3. How about the order of the second matrix? Order of the second matrix. Joyce, I'm waiting for your question. This one has 1, 2, 3. It has 3 rows by how many columns? 2 columns. So are the 2 matrices compatible for purposes of multiplication? Are they compatible for purposes of multiplication? What makes you think they are compatible? What makes you think they are compatible? What makes you think they are compatible for multiplication? I know why they are compatible. For me, they are compatible because these 2, the inner values are the same. The inner values are the same. The 3s, these 3 are the same. Then the resultant matrix, after I multiply, the resultant matrix will be defined by this. This will be a 2 by what? A 2 by 2. So the inner numbers help me assess compatibility. Then we have, in this case here, the outer numbers. They define the resultant what here? Matrix. The order of the resultant matrix. So when I do my multiplication and then I get a matrix which is of a different order, then I will not be right. So from there, let's get ahead with serious business and do this multiplication. Whenever I'm multiplying, remember, it is row times column. Row of the first matrix multiplied by column of second matrix. This is where we really get what we call Roman Catholic. 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 I'm Catholic. Very good. Very good. Now, ladies and gentlemen, very case, I would want us to run. So we have this 238 is row 1. Yeah. A very good student. We happen to be having our first row. The first row is this 238. Yeah. We multiplied first row of the first matrix to be multiplied with this first column of the second matrix. Let's do the multiplication. Remember, it is Roman Catholic. It is this row with this column down. So we move now, right? So how do we move? First elements multiplied, these ones here, 2 and 4. Second elements multiplied, 2 and 5. Third elements multiplied, and then you add all the multiples. So first elements, that will be 2 times 4, plus second elements 3 and 5, 3 times 5, plus third elements 8 times 7. Now remember that this rule will not get tired until it multiplies all the columns of the second matrix. It has multiplied the first column. Let it multiply the second column. Second column here will be 2 times what here? 2 times, somebody is following, first ones, plus second ones. So second ones, what do we have here? 3 by 9. Now multiplying this with this. 2 by 6 plus 3 by 9. 3 by 9, sorry. Let's go back a little bit. Plus 3 times 9 plus, ladies and gentlemen, 8 times 2. Yeah, as the adjusted transport cost. As the adjusted transport cost. As the adjusted transport cost. So can somebody in this case here come and pick this now second row? So this second row will multiply all the available columns. Yeah. So we have here 4, 6, 1, multiplying with first column of the second one. 4, 5, 4, 5, 7. It's very easy to multiply. Remember, it is first ones multiplied, plus second ones multiplied, plus third ones multiplied. So what do I have here? 4 times 4, first ones, second ones, 6 times 5 plus third ones, 1 times 7. And then the same row, this 4, 6, 1, it has to finish its business by having multiplied it with the last column there, 6, 9, 2. So first one's multiplied, plus second one's multiplied, plus third one's multiplied. So we have here 4 times 6, plus 6 times 9, plus 1 times 2, like that. There's somebody who can give me these answers. Anybody who can give me these answers? We start with the first one here. 2 times 4 plus 3 times 5 plus 8 times 7. But first, you may think it's very difficult, but as we continue, like it, eh? How about this one? 5, I'm told. Then we come to this one. Three. Then lastly, we have 8. You can see these are 2 by 2. We say the resultant one will be, we said here, the resultant one will be a 2 by 2 matrix. That's what we said. So anytime we are applying this matrix, remember when in school, they say you run down the ditch. In high school, if you remember very well, have this one here. 5, 4, 6, 7, 2, 1. 5, 4, 6, 7, 2, 1. We're told in this case to multiply this with 4, negative 6, 8, 9, 2, 5, 7, 3. So long as you're able to remember the concept of, first of all, check the orders. So these two matrices here of what? First one will be what by what? Roman Catholic. Catholic is column. It's by columns. The first one here is 2 by what here? Is 2 rows by 3 columns. How about the second one here? It is 1, 2, 3. Then we have in this case here 3 rows with how many columns? 3. Are these two matrices compatible for purposes of multiplication? Are they compatible for purposes of multiplication? Are they compatible for purposes of multiplication? Yes, because of the inner values here. And of course, the resulting matrix. The resulting matrix, a 2 by what here? Be a 2. And then you start now. Remember, it is Roman Catholic. You pick one row here to multiply all the available columns. I have to write whatever I had written earlier. So long as I remember in my mind, as I'm doing this 5, 4, 6, the column number 1, 4, negative 6, and 8, I'm doing at the back of my mind, first ones plus second ones plus third ones. Now I have a calculator here. I don't have to write too much. So it will be 5 times 4 plus 4 second ones times -6 plus 6 times 8. Give me a figure. Is there somebody who's getting 44, the first one? Getting 44, the first one? Or what answer you getting yourself? I could be wrong as well. I could be wrong. They're getting this 44. And pick the second one. So this row, now the second column. Because remember, first one plus second ones plus third ones. Right. Like when I pick my calculator, I can see first ones 5 times 3 plus 4 times 9 are the second ones plus 6 times 2 third ones. I'm getting 60 who? Let me see what somebody's getting there. Myself, I got 63. I got 63. What about yourselves? Yes. Speed is of essence here. The speed is not very high, then you will not be able to finish questions. Take the third one, still picking. I'm picking the same row, this third column now. Third column. First one. So it is 5 times 5 plus 4 times 7 plus 6 times 8. Anybody getting 71 anywhere? Getting 71. Third one. Anybody getting a 71? Seems they're getting 44, the third one, eh? Would expect to get many answers from you guys. Somebody is getting, let's see. What you just need is keenness and remember Catholic a column row. First one multiplied plus second one multiplied plus third one multiplied. Yeah, I like some student here with student Mwalimu, the second one is supposed to be 55. Please give me these answers, please. All of us, just be bold enough to tell me your correct answer, and then we continue. I think it's 71. The person is confirming 70. So can we go to the third row, second row here? For the second row, I'm late for my next class. My next class ought to have begun at 10. We should move and give me these answers. Like if I'm the one doing this, if I go to the second row, we'll begin with the first column. Second row multiplies the first column. You have 7 by 4. Those are the first ones multiplied. The second one will be 2 by -6. The third one will be 1 by 8. Getting 24 here. Getting 24. Then somebody has confirmed that. Thank you very much. For the middle one here. So I'm taking this second column. So we have here 7 by 3 plus 2 by plus 1 by anybody who could be getting a 41 here. 41, yes. Have now this, the last one. We have here 7 by 5. Second one is 2 by 7 plus third one 1 by 3. Give me 50 what? And somebody is able to come at 52. Thank you so much. So when I come in my next session, ladies and gentlemen, I will be able to continue with the inversion process. And then we go to our past papers. So that I do the applications. I've input what here, output, and that will be the end of the game. My name is Dr. Joshua Aura, me, the chief. I teach at RCM. I happen to be the principal. To join them, ST 525. I hope you guys enjoyed, and bye.